So where do we use it? If we learn it, it means we use it somewhere. So let's start. Let's see where we can apply electrolysis. Can you see here we have nails which have corroded? We can see the rust on these nails. The rust is the result of corrosion. Corrosion means when it destroys, it gets out of order, it becomes old. Oxidation reduction process start happening, occurring on the metal. So corrosion is like a kind of destruction. So metal is destroyed as a result of chemical or electrochemical reaction. Chemical means just we use some chemicals or we don't use. In the environment there are some chemicals which cause the destruction of metal. Sometimes it can be that there are some chemicals but also some electricity, so metals get destroyed as this result. This is called corrosion. So oxidation reduction reaction happens. Metals are oxidized, so they lose their electrons, and that's why they get destroyed. Let's now see. So sometimes corrosion is something needed, something what we need, but sometimes corrosion, very often, usually corrosion is a process that is considered to be negative, that we don't need. Look, imagine that this is a piece of steel. We have steel here, yes? And this is water, our steel in water. You know, if metal, if usually iron or steel or cast iron, they are in water during long time, they become rusted. Because in the water we have OH ions, we have oxygen atom, yes, hydrogen ion, this is iron. So it starts giving it electrons. Look, this part of metal will play the role of anode. That's why we call anodic area. This part is called cathodic area. Okay? So here, this part works as cathode. It is called cathodic area. So what happens? This part starts giving electrons, and this part starts gaining electrons. This part oxidizes, this part reduces. So here we get rust. So this is called rust, and metal gets destroyed. You see, it's rust. The rusted metal is already destroyed. It's a result of corrosion. So we can say, we can talk about two types of corrosion. Indeed, there are two types of corrosion: chemical corrosion and electrochemical corrosion. Well, chemical corrosion happens when it's a result of chemistry. That's just chemical materials. We have some chemical materials. As a result of chemical reaction, we get a chemical corrosion. Electrochemical is clear. Electrochemical corrosion is when we just use chemicals, but also electricity. Not only chemicals, but also electricity participates in this process, so corrosion occurs. So, electrolysis can be used to protect metals from corrosion, because metals get destroyed, but we don't need that. In order to protect metals from corrosion, we use electrolysis. So we can slow down the corrosion. How? We change the potential. Last time, in the previous lessons, we told about potential of electrodes. So metals play the role of electrodes when corrosion occurs. If we change their potentials, we said that the one who has a higher potential requires less energy. On this metal, we will have more electrolysis. The electrolysis will start first on that part. But if we change potential, make them lower, in this case, they will not work. Like corrosion will not happen. It's called passivation. We make them passive. And it can be done with different methods. Now I will explain. There are different ways to protect it. Look, we can use protective coatings. Like it can be like a lacquer, it can be polish, yes. It can be also any painting. So we color it or we cover it with any coating. So metal remains under the coating, and as a result, it does not corrode, it does not interact with the environment. It remains under this protective coating. Another thing what we can do is called metal plating. So it's also like painting, like coating, but we don't use a paint here. We don't use any polishing here. We use a metal. Our metal, yes, it's our main metal that we need to protect, is covered with another metal. So the other metal remains on the surface and it corrodes. The inside, the metal that remains inside just gets protected. The upper metal layer prevents corrosion. Look, so corrosion, you see, here in the picture you can see in this part we have a corrosion process, rust occurs, and this part of metal plays the role of anode because it gives electrons. This part plays the role of cathode, the cathode area. We can use corrosion inhibitors. Well, inhibitor is such a substance that slows down any process, any chemical process. Corrosion is also a chemical process. So corrosion inhibitors slow down corrosion. There are such chemicals which are applied to the surface of the metal that needs to be protected. An inhibitor reacts with metal or the surrounding gases and inhibits, it means slows down the corrosion process of the main metal. Look, we can use also sacrificial coatings. Look, this is our metal in the picture, you see, our main metal. This is our metal, and this is we have another coating from another metal, which is called sacrificial. What you do? So we take a quart. Quart is a metal which is active enough and it can corrode, it can undergo corrosion. We have steel. Imagine we have a substance, we have our material, anything from steel. We need to protect the steel. We cover it with zinc coating. This zinc, what happens? It interacts with the environment. If you remember the activity of metals, you will see that zinc is has a medium activity. It's active enough. So it corrodes. You see our zinc damaged. This coating, sacrificial coating, that damaged. It gets corroded, but nothing happens with our steel. So what happens? Zinc sacrifices himself in order to protect steel. That's why we call it sacrificial coatings. So we add a more active metal on the surface to protect it. Yes.